So the last kind of equilibrium that we need to talk about is called KSP. You remember the fun and excitement of memorizing all of the solubility rules? So you know that certain solids are insoluble. You know that sodium chloride is insoluble because you memorized the solubility rule. You know that lead 2 chloride is insoluble because you memorized the solubility rule. Well, actually, I kind of lied. All ionic compounds dissolve at least a little tiny bit. So they're not really insoluble, they're slightly soluble. So this is going to be saturated solutions. They're going to dissolve as much as they can and become saturated. And saturated solutions are equilibria. So I might write this as silver chloride breaks into silver ion and chloride ion. Now I have mostly silver chloride, but I have a little tiny bit of those ions floating around. Okay, I might write this as lead 2 chloride breaks into lead 2 ion and 2 chlorides. Again, I don't have very much of these ions. I have mostly lead 2 chloride. Now because it's equilibrium, for this I can write a K expression. So K is the products. Okay, so silver ion, concentration of that, times the concentration of chloride, over the reactants, except the reactants are solid, so we're going to ignore them. And this is called the KSP. And the SP is for solubility product. Okay, because they're dissolving, so solubility, and we're multiplying them, so product. KSP is the solubility product constant. So that's the expression for silver chloride. If we look at lead 2 chloride, it's KSP. Right? It's going to be products, Pb2 plus, times concentration of Cl minus squared, because of that 2 right there. Okay, so that's how you write expressions for KSP. It's really pretty simple, actually. And at some point I will give you a list of KSPs. I'll probably give you a copy of this table right here. So for instance, we were talking about silver chloride, and here's its KSP value, 1.8 times 10 to the minus 10. Okay, and we were looking at lead 2 chloride, and here's KSP for it. Now you're going to notice that some of these KSP values only have 1 sig fig. That's going to drive us crazy, mostly you. So you have my permission to use 2 sig figs for all of these, okay? Don't expand that to 3, but 2 is fine. Now for KSP, there's 4 things that I'm going to want you to be able to do. Okay, one is to write the expression. Well, that's all there was to that, so you know how to do that now. Okay, and then in the next 3 videos, I'm going to show you how to do these 3 things. Does it make sense if you have an expression like KSP is a concentration of silver ion times concentration of chloride ion? I bet, so I'm saying if I give you the 2 concentrations, you could find KSP, right? So if I give you this and this, then you can find that. Or if I give you KSP in 1 concentration, so if I give you KSP in one of the concentrations, you could find that. So that's all number 2 is saying. We're going to use this equation to do some calculations. The next thing we're going to learn how to do is, what if I give you KSP and we have to find both missing concentrations? So I'll show you how to do that, and we'll also see how the common ion effect comes back into play. Okay, and then also a really cool application is if I know KSP and I know the actual concentrations that I have in solution, I can predict whether or not a precipitate will form. So that will be another video. So that's it for this one, and so more coming at you.